Number 2, solve f of x equals 3 times x minus 2.5 squared minus 10.75. So we have a number of different answer choices, and several of them look like they're exact, and then we have one that's an approximation on C. So I'm going to go ahead and solve the given equation algebraically. So I have 3 times x minus 2.5 squared minus 10.75, and because I'm solving a quadratic, I'm going to set it equal to 0, because we want to know the x values when y is 0. So I'm going to add 10.75 to both sides of the equation. And the equation that remains is 3 times x minus 2.5 squared equals 10.75. Then I'm going to divide both sides by 3. 3 over 3 cancels to 1 and leaves us with the square of the difference of x and 2.5 equals 10.75 divided by 3. So if I go to my calculator, 10.75 divided by 3 gives me this crazy decimal, 3.58333. That actually means that those 3's repeat. If it's a repeating decimal, that means it can be turned into a fraction because it's a rational number. So I'm going to go to Menu, Number, and approximate to fraction. And I hit Enter. So 10.75 thirds equals 43 twelfths. And just to verify, I'm actually going to type in 10.75 thirds equals 43 twelfths and see if that's true. Yes, it is. Okay, so I'm going to use 43 twelfths instead of the other number. So 43 twelfths. And here's the part where we call this the square root method. So if I take the square root of both sides in order to cancel out this exponent, I'm going to be left with just the radicand, x minus 2.5 equals the square root of 43 over the square root of 12. And then there's something that we can do with the square root of 12. This can actually be simplified because the square root of 12 is the same thing as the square root of 4 times the square root of 3 because of our product of radicals property that states the square root of a times the square root of b is equivalent to the square root of the product a times b. And then the square root of 4, well, that's a rational number. That's plus or minus 2. And then the square root of 3 cannot be simplified, so there we have that. So I have x minus 2.5 equals the square root of 43 over 2 root 3, and this is plus or minus. Now, I can't have a radical in the denominator, so I'm going to rationalize the denominator by multiplying by whatever it takes to get rid of the radical right here. So I'm going to multiply by the square root of 3, and whatever I do to the bottom, I must also do to the top. And this is the multiplicative identity, because anything times 1 is itself. It retains its identity. So that's what we're using here, the multiplicative identity. Now, when I multiply the top times the top, the square root of 43 times the square root of 3 equals the square root of 43 times 3, which is the square root of 129. And then if I look at the denominator, I have 2 times the square root of 3 times the square root of 3. The square root of 3 times the square root of 3 actually cancels the radicals out, leaving us with just the radicand, or 3, and 2 times 3 is 6. So I have x minus 2.5 equals the square root of 129 over 6. And then I'm going to continue solving. So I'm going to add 2.5 to both sides of my equation. And I have x equals 2.5 plus or minus the square root of 129 over 6. And at this point, all I need to do is split this into two separate values. So x is the set of these two values that are 2.5 plus the square root of 129 over 6 and 2.5 minus the square root of 129 over 6, closed set. So x is the set of these two values that are this left one and this right one. So 2.5 plus the square root of 129 over 6 and 2.5 minus the square root of 129, over 6.